Okay, so now that we know how to graph equations, basically we're looking for solution points that make the equation true. Let's look at some situations that are a little unique. And the first one, you'll notice that in this example, I'm asking you to graph y equals to 4. And in the second one, I'm asking you to graph x equals negative 2. And so what makes these unique, as opposed to the equations we've seen before, there's usually an x or a y, kind of like 3. Right? There's a 5x plus 2y equals 0. So I have two variables in there, and we now know we can point plot to find the solutions. But here, right, I only have one variable. So where's x? And in this one, I have only one variable. So where's y? And if I don't have x or y, how do I graph them? Well, you still use the same stuff that we've been doing. All right. Recall what we're trying to find is an ordered pair, right? X comma y. That when I substitute in the equation makes the equation true. And so the only thing that has to make this particular equation true is that y has to be 4. So as long as you have an ordered pair that does that, you're good. So for example, why don't we just use 0, 4, right? That definitely satisfies the condition that y is 4. What about 1, 4? All right, well again, it doesn't really matter what x is, as long as y is 4, this equation is satisfied. So what about 2, 4? Well, again, that also satisfies this because the only condition that needs to be met is that y is equal to 4. So there's 3 points. Let's go graph these and get a feel for where the other solution points for y equals 4 are at. So 0, 4 is right there. 1, 4 is right there. And 2, 4 is right there. So we basically have what's famously known as a horizontal line. And the reason why it's a horizontal line is because there's only one condition that needs to be met, and that's that y is equal to 4. X can be whatever I want it to be, 0, 1, 2, or just about anything else, but the only condition that needs to be met is that y is 4. If you wanted to produce another horizontal line, all you have to do is let y equal, let's say, negative 1. And so 0, negative 1 would be on that graph, 1, negative 1 would be on that graph, 2, negative 1 would be on that graph. And so there's basically our line y equals negative 1. So there's y equals 4, and there's y equals negative 1. Of course, you can generate more horizontal lines by just simply letting y equal another number, like your favorite number, or just anything else you want. So special line, horizontal line, y is the only thing that needs to satisfy a certain condition. X can be whatever it wants. So what happens when x equals negative 2? Well, again, just like y equals 4, the only thing that has to be satisfied is x needs to be negative 2. So no matter what ordered pair you build up, the x coordinate must be negative 2. And the y coordinate can be whatever you want. So here's 3 that I generated while I was talking there. Negative 2, 0 satisfies this equation. Negative 2, 1 satisfies that equation. And negative 2, 2 satisfies that equation. So we definitely have 3 solution points to that equation. So where are the rest of them? Well, let's go ahead and go to our grid. There's y and there's x. And we have negative 2, 0. We have negative 2, 1. And we have negative 2, 2. So where are the rest of the solution points? They lie on what we now know to be a vertical line. So if you want to generate another vertical line, just basically let x equal a particular number. So if x equals to 1, we have 1, 0, we have 1, 1, we have 1, 2. And so that would create the vertical line x equals 1. And that's the vertical line, x equals negative 2. So horizontal lines, y is equal to a particular value. Vertical lines, x is equal to a particular value. All right, and so let's go to our third special case. This one's kind of unique because watch what happens when I try to find the x-intercept. All right, so what we've learned, to find the x-intercept, I let y equal to 0. So when I do this in equation, I get there, right? So 5x plus 2 times 0 is 0. Anything times 0 is gone, so we're left with 5x equals 0. divide both sides by 5, and 0 divided by 5 is 0. So our x-intercept is the point 0, 0. And if we now go try to find the y-intercept, the way that we find that is by letting x equal to 0, and when I plug that in there, we get 5 times 0, which is 0. We're left with 2y equals to 0. Divide both sides by 2, and anything 0 divided by anything is 0. So again, we end up with the same point, 0, 0. And so this is a little concerning because you know I'm going to be asking you to find 3 points, and the x and the y-intercept reside essentially at the origin. So basically, to find the other 2 points, you just basically keep point plotting. So as far as this graph is concerned, right, we know that the x and the y-intercept, coincide at the same data point, 0, 0. So where's my other 2 points? Just start plugging things in. So maybe I let x equal to, let's say, 1. So if x is equal to 1, right, we get 5 plus 2y is equal to 0. Subtract my 5, and we get 2y equals negative 5. Divide by 2, and we get negative 5 halves. So I have another ordered pair, 1, negative 5 halves, which is like negative 2 and a half. So there's another data point. So when x is 1, y is 2.5 down. Alright, so how do I generate a third point? You do the same thing. You let x or y equal a value. So how about we let, why don't we let x equal negative 1 this time? And so when I substitute that in there, we get negative 5 plus 2y equals 0. We add 5 to both sides, and we get 2y equals 5. Divide by 2, and we get 5 halves. So there's another data point. So when x is negative 1, y is about 2.5, which puts us right about there. And lo and behold, the points line up. So there's all the rest of the solutions. So what makes this equation unique is the fact that the x and the y-intercept coincide at the same point, the origin. Rather than being 2 separate points that we use on a graph, they end up being the same point. And so we just handle it by just going back and just throwing some values in and generating our 3 points. So those are some special lines. Horizontal lines where y is equal to a specific number, vertical lines where x is equal to a specific number, or those crazy lines where the x and the y-intercept actually coincide at the origin. Alright? Either way, we're still point plotting, and since we're trying to find points that satisfy the given condition. And that's basically graphing 101. So I'll see you guys in the next video. We're going to start slowly building the foundation to make graphing even easier once we understand some other underlying concepts. Talk to you guys in the next video.